Let us consider here exercise 31 that says an appliance dealer sells 3 different models of upright freezers having different storage spaces, right? So we have here storage space of 13.5 cubic feet, 15.9 as well as 19.1 cubic feet. Now let random variable x denote the amount of storage space, okay? So suppose that random variable x has PMF x, which is the possible value of a random variable. And in this case, we only have 13.5, 15.1, and 19.1 only, okay, with the corresponding probability. So probability of having a storage space of 13.1 cubic feet is 0.2. Probability of having a storage space of 15.9 is 0.5. And the probability of having storage space of 19.1 is 0.3. Okay, so the probabilities, all probabilities are positive, greater equal to 1, and they all add up to 1. All right, so random variable x is a discrete random variable. Just because there's a comma or decimal or point there in the possible values does not mean that it is a continuous random variable. The definition of again, the importance of definitions. You see, if you do not know your definitions, I'm telling you, you will, okay, the importance of definitions. All right. The definition of a discrete random variable says if your random variable takes on specific or distinct finite set of values, or an infinite sequence or a pattern where you can write down the possible values of a random variable, then we will say that that random variable is a discrete random variable. Okay, so if you do not read your definitions carefully, then you will miss the whole concept of or the different concepts. So read your definitions carefully and understand what they're trying to tell you. Okay, so since x can take on only 3 distinct values, and these distinct values are 13.5, 15.9, and 19.1 only, it can only take on 3 of these values, we will say that our random variable is a discrete random variable. There are no other values that are possible in this context, né? Or in this scenario. Okay, so we will do question A, B, and D. All right, so A says compute expected value of x. Okay, so we'll do the expected value of x and the expected value of x squared. We will leave out the variance for the next video. Okay, so the expected value of x, we firstly write down the definition. It's the sum of a small letter x times px for x, or for all x. Okay, now this is equal to, the first x is 13.5 times probability of 0.2 plus second x 15.9 times 0.5 plus the last or third x 19.1 times 0.3. Now the expected value of x is equal to 16.38. Then the expected value of x squared, what is that equal to? I said anything within the brackets, we will write down using the definition. It will be the sum of what's in your brackets using small letters times px, right, for all x. Now that is equal to, if we using this function here, the definition, we have 13.5 squared times the probability of x 0.2 plus 15.9 squared times 0.5 plus 19.1 squared times 0.3. Now that is equal to expected value of 272.298. Okay? All right. Makes sense? Yes. Cool. And then B says, if the price of a freezer having capacity x cubic feet is 25x minus 8.5, let's say rands, that's the price of a freezer, then what is the expected price paid by the next customer to buy a freezer? All right, so I would say let hx be equal to 25x minus 8.5. So I can recognize here from our proposition that it looks similar to this, right? So if hx is equal to 25x minus 8.5, then essentially we're calculating the expected value of 25x minus 8.5. Isn't that true? Yes. And what is the value of a here? A is equal to 25. Good. And b plus b, then there we have minus b. What is b then equal to? Negative 8.5. Okay. So now we could say that the expected value of 25x minus 8.5 is equal to 25 times expected value of x minus or plus negative 8.5, right? Since the proposition says the expected value of ax plus b is equal to a times expected value of x plus b. So we said that a is 25 and b is equal to negative 8.5. And so that is equal to 25 times expected value of x plus negative 8.5. But we calculated expected value of x. Isn't that true? So we calculated it here. Okay, so now the expected value is equal to 25 times 16.38 minus 8.5. And that is equal to 401 rands. Okay, so it's about 401 rands. The average price for this freezer is about 401 rands. Okay. And then for D, we said we're skipping C because it's on the variance that we'll do in the next video. D says, suppose that although the rated capacity of a freezer is X, the actual capacity, or suppose that the actual capacity is X minus 0.01 squared, okay? Then what is expected actual capacity then of a freezer purchased by the next customer? All right, so in this case, they tell us that our function is equal to X minus 0.01 capital X again squared. Now they want to know what's the expected value of this function, right? That's the question. So we know that by definition, expected value of hx, capital X, within these square brackets is equal to sum over all possible values of x. We have here a function of possible values of our random variable x times px. Okay, all right. So now this is then equal to the expected value of x minus 0.01 x squared. And by definition, or using the proposition, this is equal to the expected value of x minus 0.01 times expected value of x squared. Okay. And this is equal to that 16.38 minus 0.01 times the 401. That is equal to 13.66. All Alright, so you can do it in that way, or you can say expect the value of x minus 0.01 x squared using the definition itself, then summing over all possible values of x. We'll have here x minus 0.01 x squared times px. That is equal to the sum x times px minus 0.01 x squared times px for all possible values of x. That is equal to sum of x times px for all possible values of x minus 0.01. If you have a constant, you can put it right in front of your summation sign. X squared times px for all possible values of x. This, by definition, is equal to the expected value of x minus 0.01 times the expected value of x squared. Okay? And then since we calculated these, it will be 16.38 minus 0.01 times 401, and that is equal to, no, sorry, it's not 401, I made a mistake, it's 272.28. Apologies. I'm sure you're like screaming, like, no, you're making a mistake. Well, I can't hear you. 272.298. Okay, this is 272.298. So then it's 16.38 minus 2.72, no? Okay, yeah. No, I just, it's correct. I just wrote down the incorrect value of expected value of x squared. 272.298 is equal to 13.66. All right, good. Happiness? Happiness. All right, so now your homework, which is not for submission, is to go through examples 3.15 to 3.22. Gosh. And you can exclude examples 3.18 and 3.19. And also do exercise 32. All right, so do your homework. It will help you understand the concept much better. All right, and if you do not understand the examples or even the exercise, do post your question under the discussion board. And for this specific exercise, do include then your attempt. All right, good.